Well, we're going to be adding and subtracting payment. Yeah, because we're going to be like taking away from the balance, right? So this would be a recursive formula there. 1 plus 0.07 over 12 times a sub n minus 1. That just means previous payment, previous balance, minus each payment. So then to find a sub 1, well, a sub 1 is just going to be then all this stuff. And then n for this would be a sub 0, right? Because it would be one less. A sub 0 is the initial amount. The initial amount that they borrowed is 180,000. So that's what goes in here. And then for that first one, you can compute on your own. You can use your calculator, but you don't have to like plug in the whole sequence. And then if we found the second payment, we would take this answer, plug it into A2, right? And then take that. It's called a recursive sequence because you need to know each one in order to get the next one, right? So let's. Yeah. Hey, let's look at this. Apparently, it's just first period. You can see it. Are you this envelope outside it's like keep okay, yeah. It says geometry is going to be periods 7, 8, 9, and possibly 10 period. Well, you already took that. That was freshman year. Yeah, freshman year, right? So I don't think you're yeah. What? We're going to do that in just a second. Alright, so this first payment, you didn't have to plug anything special in your calculator other than this, alright? Just plug this in exactly, that'll give you a sub 1 because it's your interest, this is your interest part, this is your previous balance, a sub 0, and then this is your payment. And when you do that, this is what you get. 179,852.46. So just look at that number. Is there anything that's kind of like surprising about that? It is, yeah. What's surprising about that amount? Yeah, we paid like almost $1,200, right? And they did, and yet the amount only went down like $148. That kind of stinks, right? You pay $1,200 and the amount only goes down $148. So this is how interest works with a big home loan, and this actually isn't that big of a home loan. Yeah, so they're making a lot of money off of you here, and I want to show you this. This is we talked about amortization the other day, and this is a hypothetical like the same $180,000, and let's say you're going to purchase this house right here. It just went contingent, but it's about $180,000. This would assume no down payment, but let's just say you got $180,000. You're going to get a loan for $180,000. Nice renovated inside. house there. All right, so you're going to purchase this house. So this is an online calculator, which we're going to do it on our calculators as well, but this is a little bit more friendly to see it here. So 180,000, and we're going to do a 30-year mortgage, which is typical. Current interest rates range from anywhere from like 4.5% to 5%. So you calculate that, your monthly payment ends up being $938. So a little less than this problem because this was 7% interest, which is pretty high. Because if you have really bad credit, you might get an interest rate like that. But here, this is called the amortization table or schedule. All right, and then it shows you after your first payment here, if you made a payment in May, well, you would pay this much. $226 would go towards your principal, so they reduce your balance for that much, and you're going to pay $712 in interest, right, on that first payment. So only $226 of that is going to your actual loan. The rest you're all paying in interest. And you can see that's the case for a long time. You're paying a ton more interest, and look how this adds up. So like in the first year to May 2023, all right, you will have only paid off, well, your interest, you would have paid almost $10,000 in interest through your first year, right? And your actual balance has only gone down by about $3,000. You paid $10,000 interest, and you've only paid down your balance by $3,000. This site's kind of neat because it shows you the amount after every single payment that you make for all 30 years. And what you'll see is, when you start, most of it's going towards your interest here. So this is how much is going to your principal, and this is how much is going to your interest. If you find where it flips, you can kind of see how this one's going up and this one starts to go down, because as the amount of the loan decreases, the interest is less. So eventually you get down to about, let's see, past it here, right here is where it flips. Okay, so here is where you start actually paying more towards the principal than the interest. So isn't to the year October of 2037, like 15 years later, do you actually start paying more towards your loan than you actually do in interest? So halfway through the loan. And you're also halfway through the loan, and you still have $117,000 left. So you've only paid off like about $62,000, and you still have that much left. But what happens is at the beginning you pay a lot of interest, and then as you get towards the end of the loan, most of your payment now, when you're paying $700 and you're paying in your actual mortgage, and then the interest is less and less. As the overall amount of the loan gets lesser, the interest gets less. And then by the time you get to the end of the loan, you're doing mostly paying towards the principal and very little interest. Unfortunately, how home loans work is that you end up paying tons and tons of interest at the beginning, and at the end, finally get to pay off the balance. But if you had this for 10 years, you might not have paid off that much of it, unfortunately. Another thing to consider is this interest rate. Okay, it actually is a really big deal, your interest rate. So right now, like I said, they're kind of high because inflation is kind of high, but sometimes they get pretty low. Like when I initially bought my house, it was like around 4%, but then I was able to refinance my house. I think it's either 2.75 or 2.875 to refinance my house. So just watch to like what changes to the payment. Let's say you refinance, you got a low interest rate. Interest rates were low, and a refinance just means you sort of get a new loan to replace it, right, with a different bank. And so when I calculated that, it's going to go from 938 down to 746. So it reduces your monthly payment by about $200. Your interest rate makes a big difference. And another thing that you can do to lower the amount of interest that you pay is let's just say like maybe 3.5% here, is not do a 30-year loan, but if you do a 15-year loan. And this is common for like someone that's maybe in like their 40s or 50s and they buy a house, and they don't want to pay on their house until they're in like their 70s or 80s, right? So they'll get a 15-year mortgage instead. And it does increase the payment, but it only went up by like $300 and some, right? It didn't double the payment. Okay, and this is good because when you look at the beginning, you're actually paying more towards the principal than you are in interest already at the beginning. So this is good because since you're paying it off a lot faster, you're paying a greater chunk of your mortgage each time, and you're not wasting as much money in interest. So if you can afford to do the 15-year loan, that's definitely a good thing. If you can afford to lower it to 15 years, you end up paying a few hundred more a month, but you're going to pay it off a lot faster, and you're going to save a lot of money in interest too. So those are things that you can do to reduce your payment, get lower interest rates, and also reduce the mortgage term to 15 years. Occasionally you'll see 20 years, but if you're older in your life and you don't want to pay for 30 years, you might want to look at a 15-year mortgage.
How about the end of how about the prices?
Or if you can afford it, even do it earlier, right? Okay, so let's look back at this problem real quick here. We're going to do this on our calculators. So grab your calculator out, and I'll kind of remind you how to do this. We're going to type this recursive sequence into our calculator, and then we're going to figure out when is it going to be below 170,000. All right, so the first thing that you need to do is, what should we check first? Remember?
Check the time.
We want to check the mode here. You're going to hit mode first. This might be good because other classes have been using it. But you want to check your mode, and you go down to the fourth line. You want to make sure you're on sequence, not function. Function is where we've been most of the year, but we're going over to sequence and hit enter on sequence. From there, you're going to hit y equals, because that's where we type in equations, right? We type them into y equals. So hit that. And it'll look something like this. Clear out my previous stuff. And if you have other stuff, go ahead and clear it out. The first one, you're just going to leave it as 0 always. We'll talk about that more in just a sec, but always leave it as 0. This u of n is where you're going to type in your sequence. And the u is the same thing as like the a would be. So u of n essentially means a of n. Calculator chooses u instead. So we're going to type in our equation. It's going to be parenthesis 1 plus parenthesis 0.07 divided by 12. And close your parenthesis twice. So that's the interest part. And now we got to do u of n minus 1, same thing as a of n minus 1. So to get the u, we look down here at 7, and you'll see there's a u right there. We're going to hit the second and then 7. And that will give us a u. You're then going to do parenthesis. And then you're going to hit this button here, this xt theta n. The n is what we want there. There's a little crooked n, so we want that. And then you do minus 1. Then you close your parenthesis. So that's how we do a sub n minus 1. At the end, you hit this little. And then minus 1197.54. Very good. Okay, now we're gonna just go ahead and hit enter, and we're gonna type in something for that u of n min. This just means like our starting amount, like the a sub 0. So we're starting with 180,000. So we're gonna type that in. Hit enter. This 0 just means like where we're starting. We're starting with like times 0, so that's why that's 0 there. These two kind of just go together, the n min and u of n min. So at times 0, a sub 0, we're at 180,000. Okay, then you're just going to hit second and then table. Depending on what numbers are plugged in your table, it might take a little time to calculate this because it has to do all of the terms in the sequence. I should have checked my table here first, probably just taking a little while. There we go. All right, so let's just start with 1. Set 1 and enter. And if your calculator is not allowing you to type anything, you need to hit second and then table set up here. And just make sure that this independent one is on ask, and then the dependent should be on auto. So second table set here. If yours isn't working, then you can just go back to table, second table. So you can see if you start typing 3, 4, and this represents the balance of the mortgage after each payment. So after 1, we're at 179,852, and 704, then 555, 405. You see it going down there. The question that we're asked to find is when will their balance be below 170,000? So we can just plug in random numbers. Let's try 20 after 20 payments. Nope, let's try 40. So you're just basically guessing and checking until you find where it drops. 50. Not yet. 55. Not yet. No. All right, so at 57, we're at 170,057. It looks like the 58th payment is when it drops below. So after 58 payments, it will be, you'll have eliminated 10,000. So you'll have made, 58 times 1,200 or whatever, and then you'll have paid off 10,000. Is everyone getting this? Logan, no?
I think I might have missed on the first one.
Okay. Yeah, it's just finishing the equation. It's the minus 11. Here. It's this 11 and 7.5. Yeah. Oh, you just have to type in the number 1.
I get 4, 4, 4.
Alright. Good. Alright, we're going to go and try the next one. So if you weren't here Friday, we talked about these, talked about annuities and amortization. Annuities are when you typically add money to something, right, so it can grow. And amortization, kind of the opposite. You're loaning money. Both of these, you periodically either invest or like pay off money, right, every month or every quarter or every year. And then we have these two formulas, right? So we're going to use those to answer our next question. Here we're going to look at the trout population. Yes, the trout Yeah. Any food is going up in price right now, so yeah, animals.
How old is the type of trout population?
All right, so this is a pond at a fish hatchery. So fish hatchery is basically a place that raises fish and then they sell them to restaurants, things like that. But they raise them in their ponds. So there's like shrimp hatcheries, things like that as well. So at this fish hatchery, there's a pond that currently has 2,000 trout in it, and they're going to add an additional 20 trout each month. In addition, it's known that the trout population is growing at 3% per month. The size of the population after n months is given by the recursively defined sequence. So it's giving us the sequence. We don't actually have to calculate it. Our starting amount is 2,000, and they've already written the sequence for us. They simplified it a little bit because it'd be 1, really, it would be 1 plus 0.03 over our 12s, but they've already done that for us. So we're saying this is what the sequence is. So we're going to use this sequence. The first question is how many trout are in the pond at the end of the second month? Right. So what we're going to do is flip back to our y equals. You can just go and hit that. And I would just go ahead and clear the u of n. And we're going to type in that formula. So 1.03. And then we got to do our second 7 to get the u. And then parenthesis our n minus 1, close parenthesis. So it's 1.03 times the previous term. And then we're adding 20 trout, so plus 20. And our starting is 2,000, so we're 2,000.
Do you think that like this would affect trout population?
Yeah, looks like
Exploding.
All right, and then go to your second table. So after 2 months, or I think it's just 2 months, we get up to 2,162. So it's gone up, not 40. We put in 40, but it's gone up 162. Right, and then we're asked to find how long will it take till the trout population reaches 5,000. Maybe when it reaches 5,000, that's like the most this pond can hold, right? And there's no way to actually count all the fish inside the pond. You know, you're not gonna go down there and scuba and try to count 5,000 fish. So you're gonna have to estimate it, right?
I'll do it.
26. What you got?
It's roughly 26.
Yeah.
5,000.
All right, yeah, so 25, we get, yep. Yeah, so by the 26th time, we'll have over 5,000. A lot of environments have what's called a carrying capacity as well, right, where the environment can only support so many species.
Oh, I remember that from
So like this pond can, probably only hold 5,000, and then there's not enough resources for them. All right. We're gonna look at one more here. So the last one we're gonna look at is an IRA account. And if you Google IRA, then you're going to get the Irish Republican Army.
I love the rock. Love the rock.
But we're talking about a different IRA, which is the individual retirement account. So there's two general types of an IRA. You might have heard of this before. There's a traditional IRA and a Roth IRA. There's one major difference between them. A traditional IRA is like you get to take the money before you pay taxes and put it into an account. But then when you retire and you take it out, you have to pay taxes on it. So like you're deferring the taxes till later. With a Roth IRA, you're already going to go and take the taxes out of it, and then you put it in your retirement account. And then when you take it out when you're older, you don't have to pay taxes on it. So either one is fine. Just, when you want to pay the taxes now or later. And I don't know. I think for most people, it makes sense to do a Roth IRA, so you're not like, thinking you have all this money when you have to pay taxes on it. Probably better if you just know you have that.
I really hate market.
Retirement savings and then
Right.
I really
Right.
hate market that.
And taxes generally only increase; they don't really go down much. They just keep adding new taxes. So and you can probably count on taxes being higher in 30 years than ever.
What if we transition to a fully trout? So what happened to taxes?
are there trout at Dillon? Are there trout in Dillon?
He said
Not restricted.
He said like trout in a piece.
All right, let's see if we can write an equation for this. This one doesn't give us a recursive sequence, so we got to write it. We got a recursive formula. Liam's gonna deposit $1,500 to start, and into his Roth IRA. Then he's gonna put $750 at the end of each quarter. So every 3 months, he'll put in another $750. We're gonna find a recursive formula if he's gonna get 5% compounded quarterly. All right. So let's see if we're gonna write that. It's gonna be A sub n equals, let's see, 1 plus. Our rate is going to be 5%. It's going to be 0.05. And since this is quarterly, the end is going to be 4 in this one. We then have our A sub n minus 1. And then are we plus or minus the payment? So plus or minus the P. Plus or minus B. Plus B. You're adding to some account, right? Alright, so we're gonna put 750 in. And then our A sub 0, our starting amount, is that 1,500 that he put in initially. So let's go ahead and plug that in. Take a second to see if you can type all that in to your sequence there. So you should have your 1 plus 0.05 divided by 4, U of n minus 1 plus 750. Don't forget to change your UN men to 1500. Your U men should still be 0. All right, let's look at our table. All right, we're supposed to determine how long until he gets 150,000 in that account. This is quarters, so go ahead and just guess and check some. For 50, he's got 54,000. 75. Okay. 75, yep, is 96,000. That's good. 100 is just over. Yep. Alright. So you can see this is when interest starts to work in your favor, right? So from payment 98 to 99, it jumped over 2,000, right? $2,033, and you only put in 750. So this is how you get interest to work for you, right? Because you got this big amount saved, and it continues to grow a lot, even though you're not putting in that much relatively, right? So after 100 payments, so if you divide that by 4, because we're doing it quarterly, so that would be 25 years. 25 years, he'll be up to 150,000. Now let's say he decides this is not enough because nobody's going to be able to live off of that in 25 years. So instead of doing this quarterly,
That's one both of them.
instead of doing this 750 quarterly, let's say he changes it to monthly. Okay, so he decides I need to do this more than once a quarter. I'm going to do this once a month. So I'm going to change this to 12, and then just fix everything here. Let's see how that affects it. See if we get a fair amount more. So just change that one value. So our table looks like. So it took a little time to calculate. All right, so now after 100 payments, we're at 95,000. But we got to consider this. Is this the same amount of time? 95,000. This is 100 payments, but we're talking about months now, right? Okay. So the same. Let's say 20 years. How many months is that? 20 years. 240, right? 12 times 20. So the same amount of time, like 20 years, would be 240 payments because now we're talking about, and now we're up to 312,000. So we have more than double this. So that's good. Let's say we want to do in 30 years. How much is he going to have in 30 years? Which I think the question asked 30 years retirement. If you up this to every month in 30 years, 30 times 12 would be 360. So takes a second here. Think about it. So then you'd be up to 630,000. So that's probably a lot better, right? It does it monthly. Seems more sustainable. And then you can mess around with this. Let's say if he wants to get up to 1 million, you could change around the numbers a little bit. Let's say he's going to instead put in, let's say $1,000 a month. So like 500 from each paycheck. And see how that affects it. Calculator a second here. And don't plug in like super big numbers or else we'll just do this forever. All right, so 360. So after 30 years, we're at 838,000.
Bless you.
There we go. So 1,000. All right. The last, let's see, 15 minutes or so, I want you to try to answer a couple questions. There's a total of 4 that we're going to do over the course of today and tomorrow, but I'm just going to have you do 2 of them today because not everyone has these calculators they can use at home. So I want you to do these. Try to start on these first 2 in class today. If you don't get them finished, that's okay. I'll give you some time tomorrow to work on them. But try to do those 84 and 86. They are on